talk is called Observability for Java Devs, and the word Java is in brackets here, and that is for a very good reason, because as you'll find out, a lot of what I'm going to say applies to things which aren't Java. And Java is actually a very good example of an observable language, but it's not the only one that we have out there. Okay, so looking around the room, I think I know a few people here, but it has been a few years since I was at Devnexus. So let me just introduce myself real briefly. So my name is Ben Evans. I'm a senior principal software engineer and the lead for observability at Red Hat Runtimes. Before that, I was lead architect for instrumentation at New Relic. And before that, I founded a company called JClarity, which was a Java performance company that we sold to Microsoft in 2019. So I've been involved in the performance space for a very long time, even going back as far as the Google IPO, where I was the lead performance engineer for testing the systems used for Google's IPO. If you want to hear some of those stories and find out where some of the bodies are buried, come and find me in the bar later, okay? I'm also known for some of my work in the community. I'm a Java champion, a Java 1 Rockstar speaker for those of you who are old enough to remember Java 1. And I've done a bunch of other things, such as serving on the standards bodies that look after new Java standards. I live in sunny Barcelona these days, but I spent many years working as part of the organizing team for the London Java community. And we did a bunch of things, including starting a project that you might have heard of called Adopt OpenJDK. I'm also an author. So two of my most recent books are The Well-Grounded Java second edition and the new edition of Java in a Nutshell. And I actually I'm fortunate enough to have my co-author with me today. So we're going to be giving away a couple of copies of each of our books at the Red Hat booth a bit later on. So my buddy Eric is also giving away free books. He's got more than 4 copies. He's got a lot more. So if you want to hear about Quarkus for Spring developers, or you want to see if you can get one of the slightly rarer other books, then come along at 2:45 p.m. today. Okay, so that's enough about me. Let's do some observability stuff. There are a bunch of demos. I'll put this up for like 10 seconds so that people can take a picture of it if they want. I need to go quite quickly because this material actually normally comes in a 2 to 3 hour serving size rather than the 1 hour I've got today. So I'm not going to get into any IDE today because there's just not time. Okay, so what are we going to talk about? Yeah?
Is there any way to increase the volume on your speaker?
I don't know. Where's my AV person? They're not here. Yeah, I mean, if someone can shut those back doors, that might help because there's still a certain amount of noise coming in. Yeah, all of the doors. That's a good plan. Thank you. Okay, so what are we going to talk about? And I'll try to project a bit more, give my, hi. Yeah, my mic's still quite low. So what we're going to talk about really is sort of 4 main topics to talk about the concepts of observability, because a lot of people still have this conception of observability as this very vague thing, and that's not actually accurate. Observability is actually quite well defined, and you can actually be quite precise and quite methodical about how you talk about it. So just to take a few minutes to clear that up to make sure that everybody is on the same page, everybody knows what we're talking about. Then I'm going to talk about OpenTelemetry, which is one of the major projects which is happening in the space. And it is not too many spoilers to tell you that the growth rate of OpenTelemetry is really quite unprecedented. It's very, very sharp. Lots and lots of people are adopting it. And it really, if I was a gambling man, I would be prepared to put some money that OpenTelemetry is going to be a major open standard in the coming years. Having introduced the concept of OpenTelemetry and what it means for it to be a standard, I'll also talk about Java and OpenTelemetry and how those parts fit together. And then to wrap up, I'll give you some concluding thoughts and the future. Okay, so let's start with what is observability? What is it? Why do we need it? Why is it important, very much especially for cloud-native applications? I mean, so if I was to say observability, what sort of words would people think of? Let's throw a few things out there and see. Put your hand up if you've heard of it and you think that's kind of related to observability. So obviously the big one is kind of Prometheus. Who's actually using Prometheus? Hands up. Lots of people. Okay. There's some interesting stuff. We'll talk about that a bit more detail later. And then, of course, there's logging. There's all kinds of logging solutions, and I'd be here all day if I just listed out all the possible logging solutions and products, whether they're vendor or open source, that people are using. One which is, I think, particularly interesting is FluentBit. Is anyone using FluentBit or FluentD? Yeah, a few people. Okay. And then, of course, the other piece, which is, I guess, tracing. So tracing is the other form of observability data that we're going to talk about a lot. And that one is kind of governed by OpenTelemetry. So if you're using OpenTelemetry tracing, put your hands up. Only a couple of people. I would have expected more than that. What about Jaeger or Zipkin? Anybody got those? Okay, again, I would have expected a few more, even though they are much more legacy products now. But okay, so it's good to see that it wasn't always the same hands going up as well. So what that's telling me is that there is some general awareness of observability, even if people aren't that clear about it yet, okay, which is about what I thought. So what is observability? It's conceptually simple. You instrument your systems and applications to collect this observability data, and every time I have to say this to a room full of people, I feel embarrassed that I have to explain this architectural point. But the reason I do it is because you would not believe how many people have not figured out the thing that I'm about to tell you. You gather data in your applications because you're going to use it for diagnosing and fixing problems. You have to send it to a different system. Because if you don't, the data you need to diagnose your production system, which is down, is in your production system. Right? That sounds like the most basic and stupid architectural point that you could possibly think of, but some of the names of some of the firms who have failed to do that correctly, I'll spare the actual names just because it's it's a little embarrassing. Want to hide their blushes, but more people than you would think, and people who you would really think ought to know better. Okay, so you send it to a separate system which stores and analyzes it. And then what you need some way of storing it, you need some way of visualizing it. And if you're thinking about this in terms of something which looks like a graphing interface, perhaps with some kind of query language attached to it, then that gives you the sort of flavor of the system that you're building. What's interesting about that, there's a few things that are interesting about that, but one of the main things that's interesting about that is that it implies that this is a different sort of set of skills than developers. And that point, and the reason why that is the case, is the subject of, I think, the next slide. So the overall aim of this is to provide insights for DevOps, management, SRE. Why are things going wrong? And what you discover is that there's this idea, I think it's originally from Charity Majors, who's the CEO of Honeycomb, one of the main players in the space. And Charity says that the thing which distinguishes observability is you find yourself needing to get answers to questions that you didn't know you'd have to ask before you started. And that is really what characterizes it, because that shows you that it's a very exploratory, it's a much more data science-y type of work that you're doing. It's very different from software development. Okay? So if you want the high-level theory, if you like lots of theory, you can consider this to be a form of systems control theory where you're inferring the internal state of the system from outside. And what you want to build is towards actionable insights. So to give you a very brief example, my red hat cuts off the end of my URL here. But anyway, this is an example of a piece of observability work I did last year. And it's basically looking at the impact of what happens if you run Java in single core containers. Spoiler, don't. Okay, if any of you are running, actually that's a good question to ask. Hands up if you're running Java in containers already. Okay, keep your hand up if you're running Java 8 in containers. Yeah, you want to not be doing that for definite. Move to 11 or 17 because your applications are in danger of outages, and nothing further is getting backported into the Java 8 line to fix the problems that there are with containerized Java 8. Get off of it. It was fun while it lasted, but the time has come to wave goodbye to Java 8 and move into the modern world. So people who are running Java in containers, who is running in containers with only one core? Or people don't know because there's all that sort of millicore business. Yeah. Basically, there are a number of reasons why it's a bad idea. The main one is modern garbage collectors, especially G1, are concurrent. If you run in a single core container, you do not get the garbage collector you think you do. Regardless of what you tell it, you get serial. And virtually nobody wants serial. Okay, so you are giving yourself bad performance for no reason whatsoever. So there must always be enough cause that the VM thinks that there are two of them. Okay, and there are a number of ways to arrange that. I won't dwell on it. Okay, so this idea that we have observability to try to figure out some of these sorts of problems and look inside our containers and our applications, it's not a new idea. It's been around 15 plus years. I mean, I spent some time working at New Relic, and New Relic was one of the first big APM vendors. But it was a different world, right? When I started working, when I was working on the Google IPO and those types of things, you had, well, release cycles that were measured in months. It's quite common to have 2, 3, 4 months between releases. You know, our architectures look basically like this, right? This is a 3-tier architecture. There's still nothing wrong with the 3-tier architecture. For all sorts of problems, it's fine, right? You don't need to deploy Kafka and auto-scaling and all sorts of complicated things just because you can. For many problems, this will actually do. But to return to the previous slide, we have release cycles in months. These are really monolithic, and they're on-premises. They're not cloud native. I remember very clearly when I started at Morgan Stanley that we would have, every 6 months, I'd sit down with my boss with a cup of coffee, and we would try to figure out how many machines that we needed to buy to have physically shipped to our data centers for projects wouldn't even start for 3 months. Right? That is the sort of capacity planning we had to do. And that is what the cloud really is and really solves. It's a movement of capital expenditure to operational expenditure. There's a load of technical stuff that goes on top of it, sure. But fundamentally, that's what the philosophical point is. Okay? Now, when you put these things together, you can see that you can sort of do manual and semi-manual instrumentation of all of this. Why? Well, because your architecture is stable. Your architecture is known, it's relatively simple, and it does not change for months on end. So a good operational team has a pretty good idea of what can go wrong. Okay? That is, I'm afraid to tell you, in case anyone was laboring under any illusions, that is no longer the world we live in, and that world is never, ever coming back. So we have to deal with a world which is profoundly different along many axes. But the most important, the most critical, if you don't take anything else away from this talk, take this away, is that the rate of change is the primary driver. Your architectures are not stable anymore. You have a bunch of microservices. Next week, some team that you've never heard of might put something into production which suddenly starts hitting your service. Your load pattern now looks completely different for something you had no control over. And the larger your organization, the larger the software development and DevOps all is, the more true that is. So that is really the major point. This is why we need observability. Because everything's more complicated, things have more rapid change. Yes, there are also genuinely new technologies. There are things like Kubernetes and Kafka and functions on a service, dynamic scaling and all of that good stuff. But those are just other interesting complexities that we have. The fundamental point here is architectural. It's about the rate and amount of change we have to deal with. I'll skip that one about Java containers. So because I work for Red Hat, I'm obliged to show you at least one slide with OpenShift on it. So here we are. So a distributed system these days looks much more like this. You see there's lots of components. That the layering structure we saw in the 3-tier app is gone, and now there's just a bunch of things calling each other. They're not even all Java, which is also interesting, which I'll come back. Those days are also gone. The days where a company was purely Java and that was all they did, front to back, are also gone forever. Then, of course, we also have things like this, which now doesn't even look anything like a service or a tiered architecture at all. It's just some things which are running in the cloud. There's a lot of data. This is all a kind of a serverless architecture that's running here. So architectures change, and we need a way of figuring out what's going on inside our applications, even despite all this radical change in how we architect them. Okay? And apart from anything else, the user perspectives haven't changed. Users still want to know the same things. They want to know, how is the solution doing? What are my root causes? What are the performance bottlenecks? And what is potentially impacting customer experience? Right? Those are probably the top 4 questions that any user of an observability system is going to want to answer. It's also worth noting that the other aspect of this, which has changed lately, and I was actually at New Relic when I saw this change going on, is we've moved from something where the biggest players are all vendor and proprietary to a world where much of this loop is now open source. And that is one of the big transitions that I'm going to talk about. Now, why that happened, I think, is for people who've been around in the industry for a long time, and I've been working with open source software for nearly 25 years, this happens again and again in different vertical markets. You have a commoditization of the lowest layers, the value which become open source, and the value migrates up the stack. And that is what is ongoing in the observability and monitoring market right now. It's been going on for a couple of years. I was actually part of the team, technical lead for the team, which led New Relic's open sourcing of right about $600 million of intellectual property related to their tech stack, and it's still going on. So that move, that shift towards open source has some implications as well. And when I come back to talk about patterns for architecture and how you might implement this, I'll have more to say about that. Yeah, I can probably skip that. Let's go straight into the data about what we're actually going to collect. Now, I gave you a brief trailer for this before, but these are sometimes called the 3 pillars of observability, and some people don't like these. Some people think this is a bad model. Some people think you should think about everything in terms of events. Funnily enough, those people are often the ones who also have an event-based observability system that they would very much like to sell you. That's probably a little too cynical. But after having thought about it, and especially worked with people who are just implementing observability, I actually do like this model. One of the reasons for it is because these are fundamentally different data types. They have different form and different shape, as we'll see. So trying to claim that there is like one ring, one super type, which somehow all of these things fit underneath, I just don't think is credible. Also, this is a nice mental model for people who are new to the subject, and there are still loads of people who are new to the subject. Metrics, people know what they are intuitively, likewise logs and likewise traces. So that's why I tend to still frame it in terms of these 3 pillars. There are other things as well. Some of the frontier work that's going on in OpenTelemetry includes things like events, but not as a super type, as just another data signal type that you might have. I'm also very interested in profiling, and profiling is a whole different kettle of fish. But for now, in terms of what people are doing for real production systems, it's these 3 things. So let's take them one at a time. Oh yeah, and I should have said earlier on, if people have questions, then please, I'll take questions at any time. So metrics. There's lots of, I think, most people I think have a reasonable understanding of what metrics are, but let's be explicit. A metric measures activity over a time interval. And strictly speaking, it has to be a regular time interval as well. Very occasionally, you get people who want to do things and have a non-standard cadence where the interval between the metrics can change. That's a terrible idea. If you find anyone trying to do that or suggesting it for your own monitoring systems, dissuade them as sharply as you can. The reason why it's a terrible idea, and I should explain that, is many of the statistical techniques for handling time series databases do not work except on a regular cadence. So all of the libraries that you're thinking, well, we'll just use these libraries to analyze our time series data. If it's not regularly cadenced, they will not work and they will fail in subtle ways. So that's why I always have to say that part. Generally speaking, we think of metrics as having 4 things. Well, a timestamp, which is the point it occurred at, the name, the value, whatever the number is, and then these things called dimensions. And dimensions you can kind of think of as key value pairs, right? So there is a key and it has one of a number of values. But there are 2 important things about dimensions which need to be true for them to be really dimensions rather than just tags. I'll come back to that in a sec. But let's just do a few examples. So you can think of the standard ones, right? So the CPU utilization, the memory utilization, the load average over the last second, for example. all the way up through the stack to like business level metrics as well. All of these can be thought of as metrics. And Prometheus is probably one of the most well-known technologies in the space. One of the problems is it doesn't really do a lot of the stuff that general metrics theory allows for. In particular, there's this thing which we call dimensionality. Is it the key value annotation of the metric, or is it what Prometheus does, which is to give you incredibly long names, which basically are the dimensions squashed into the name? That's essentially how they do it. It's called a hierarchical metric. And generally speaking, people are of the opinion that that's really not the way to go anymore. There's also the aggregation discipline. So this basically is how do you aggregate your metrics? One of the most important things about metrics is because they are a value represented over a time interval, you should be able to aggregate them. Yes, you're losing information every time you aggregate, because that's what we do. That's what our statistical techniques do. They are throwing away information in order to get simplification from it. So the aggregate could happen at multiple scales. It could happen on the client side. It could happen in the server. And the way that a metric system feels about dimensionality and aggregation discipline is quite important in terms of how the maths works. Finally, there is how does the data get from your production system into the observability system? And there's two ways of doing it. Either you scrape it out of the application, or the application pushes it to you. So they're referred to as a client push or a server pull. So now you can sort of get a flavor that different metric systems might operate in different ways. The way that Prometheus does it is very, very opinionated. I'll talk more about that when we get on to talk about OTel. The OTel architecture is completely different to the Prometheus one, but here's the thing. Metrics are actually something that we can really do quite effectively in Java. And in particular, we have Micrometer. Hands up if you use Micrometer in your apps. Okay, more people I think would be good to be using Micrometer, because it's in my opinion, easily the best of the metrics libraries. It's well architected, it's well thought through, and it has that nice property that, for example, SLF4j has, right? With SLF4j, you want to change your backend log provider, you just change a bit of config, include the right jar for the appropriate exporter, and nothing in your application changes, right? So what it provides is a decoupling layer from the application developer to not have to care too much about where the data is actually going. Micrometer provides you with the same thing. It provides you with a way to do metrics without having to be overly concerned with where they're actually going to end up. So this is one of the examples, and I'll come back and I'll talk more about this when we get onto the OpenTelemetry stuff, where we actually have it quite easy as Java developers, because for metrics, we just have this nice abstraction. And no matter what the rest of the world converges on, we're pretty sure that we'll be able to join them. So that's kind of really handy. So the next familiar one, of course, is logs. And logs, I like to give this definition, they are immutable records. You don't mess with a log after you've generated it. It's generated by the application. It's generated at a specific point in time. Already we can start to see that some of the data aspects which are different between these data types. Metrics refer to a single value represented over a time interval of some width. A log is something which is point in time. You can encode them as text and binary. That doesn't actually matter. You also can do all sorts of other combinations. As I discussed, SLF4j / log4j are probably the most example of what are called log facading patterns. You set up a facade, you send logs into it, and apart from that, it goes to wherever it's going to go. That's also worth noting, because sometimes people get this wrong. There are two types of logging systems. There's what's called a centralized logging system and a distributed logging system. Don't assume that because you have a distributed system that you have a distributed logger. You almost certainly don't. It is very, very common to take all of the logs from a distributed system and send them to one place. That's a centralized system, not a distributed one. A distributed logging system are much less common, and that you basically only do this when you have to. If there is something like you are producing so many logs that it will swamp the bandwidth of your network, and actually you'll interfere with your own application performance because of how many logs you're generating. At that point, you kind of have to deal with them locally and actually only have a distributed log. But in general, when we talk about logging, we are always talking about the centralized logging pattern. Okay? There's not much to say about logs, you see, because we kind of all know how logs work. We know some of the pitfalls. We know that it's very easy to write logs which aren't any use when you come to debug a production system. We all know the anti-pattern that if you find yourself needing to log in debug in production, that's bad. We know how logs work. So let's spend a bit more time on tracing. So tracing is effective, and distributed tracing. I think we tend to leave off the word distributed, but I think for many people we really should include it. It's per service. So there's an entry point where something in a client system, maybe a browser, hits a service in the back end for the first time. And from there, many other calls and many other interactions may be spawned in order to handle whatever request was made. So this is what we call a service invocation, and a trace can be generated for every single service invocation. And we want to get back not the data that gets returned from the service, but we want to collect metadata. What was called? Which instance? How did the request perform? What was the result of the request? Was it 200 OK or 500, or how did it work? And then what we want to do is we want to, from each of the systems that participated in that service invocation, we want to reconstruct a view of what the tracer actually looked like. And this is going to end up with what we call a tree structure of spans. A span is just one invocation. So if you have all of these different things that get called, the processing time and the call to one of those systems is what we call a span. So let's see this in action. So we have some very, very simple diagrams. It's also worth noting another piece of performance theory. That does show up, cool. Over here you have the perceived time, and then you have the actual trace duration over there, right? So there's network time, there's browser think time, there's all sorts of other things that can go into this. So when we're focusing on this, we are focusing just on this red piece over here. And you're probably thinking to yourself, why has Ben got a red dot on his slide? All will become clear. So that's fine, but we want to do microservices. So let's do this instead. Now we've got a service and a database. Okay, and now we have two things. We have an overall trace, because that top level, that entry point is our service invocation as a whole. And then further back, we have an additional span. Now you see our red dot has got a friend who's encoded in blue. So let's do another one. We're going to call not just one backend thing, let's call three separate things. So now you see that we have the overall service, the size of the trace here, and we make a call to authorization, and then with the authorization code we can now call a database, and then we can now call some storage. So now we have a single red trace with three spans in it, right? And so this is how we build up our tree structure. And I'll do one more. So this one, you see, has got a slightly different topology, because what happens here is we call the database directly, and the database goes, oh, you need an auth token, let's go and get one. So then the database makes a second call to the auth service. Notice that our overall Bastion service, as it's sometimes called, never actually talks directly to auth at any point. So the tree structure now has got these two levels in it. We call storage and we call database, but database is the thing which calls auth. Okay? So I think I've shown you enough examples for you to be convinced, without me doing any more, that any service invocation can be broken down like this now. Yeah? And this is what we want to reconstruct when we put things together. So how do we do it? Well, we need some data. And this is sort of a standard format for how we would reconstruct this. I'm just showing it as some simple JSON here. So the overall trace, so this is the overall tree structure that we're going to reconstruct. We've got the span, which is the one that we currently are, and then we've got a parent span ID. And that's it. That's what you use to stitch them together. You send all of these things up into some sort of external observability system, and then it sorts them and collects the different pieces of the trace ID, and then it stitches together the span IDs and the parent span IDs to reconstruct it. And then we have the other sorts of metadata we have. We've got a start and end time. we've got some attributes, we've got a status, all of those things that we might want. Okay. So now we know how to build a distributed tracing system, but let's talk in detail about what the components actually are and what you might use for them. So there's 5 things you've got to do. You have to add some instrumentation so that either the application or the middleware knows about this. You also have to arrange for those trace IDs and span ID and parent span ID to get propagated from component to component. Now, this is implicitly all HTTP requests in the background. Can be done for other things, but for the sake of argument, we'll assume it's HTTP. So what the natural way to do that is with headers. So what and you probably don't want to do this in your application code. You probably want to have Tomcat or something else, whatever your application containers are, do this automatically. So when we talk about the instrumentation of middleware, when we talk about distributed context propagation, that's what we mean. How do I get those identifiers from place to place to allow me to reconstruct the trace later? You also need to store these things and basically turn them back into proper traces. Then you need to be able to search it and retrieve data, and then finally you need visualization. Now, you could go to a vendor and buy all of these things, and for many people that might actually be the right answer. But for those of you who want to do this in pure open source, it breaks down kind of like this. So for tracing, there's OpenTelemetry. Oh, the one thing I didn't ask about was open tracing. Is anybody using open tracing? Nobody. Good. That really should be dead by now. It's super end of life. They're not even doing security patches for it, and I don't think you can even find anyone who will sell you support for it. So I'm very pleased to see that has finally died. So OpenTelemetry provides the instrumentation. It provides the context propagation. This is actually a substandard called the W3C trace context standard, which is really what this is building upon. But OpenTelemetry is the implementation which provides that for you. You need some ingest and storage of traces, and you could use the OpenTelemetry collector. We'll talk more about that later. It's kind of badly named. It doesn't actually do storage. It just does data ingest, really. And then you need a backend to put it in. The standard one in the open source world is Jaeger, but lots of people are thinking about this product called Tempo as well. Okay, and then for the retrieval, whichever of Jaeger and Tempo you've used, you will also use that for retrieval, and this also provides the visualization. The Jaeger visualization is, I have to say, a bit clunky. It does give you a view of what we call trace view, which effectively is just the simple spans and how they telescope out and stack together. But that's yes.
Where does Grafana fit in there?
Yeah, good point. That's a great question. So Grafana, for folks who don't know, is a graphics and graphing library. So that's really for metrics. We're talking about trace data here. So I think Tempo may actually be part of Grafana now. So I suspect that actually it's Tempo that you would be looking at if you're already a Grafana shop. Yeah, at the back.
Do you ever care about metrics about your traces? Is there such a thing? Like the quality or the certain interesting aspects of trace data?
Yes, you can do. But there's a big caveat in all of this, which I haven't told you yet, which is that there is so much data which comes out of a tracing solution that you effectively have to sample it. Because if you try to take 100% of it, apart from a few very special edge cases, you get swamped in data. Yes, you could do metrics things, but the sampling would have tended to smooth out things that you would have been looking for there anyway. But it was a good thought. Okay, so the visualization is the hard part. New visualizations are needed. That's why people like Tempo, and data sampling is an issue. I mean, one of the things that people try to do in order to do smarter sampling is to sample the 200 OKs, but take 100% of anything which had either a 400 or a 500 in any part of the trace, right? Because then you're focusing on the errors, and you're taking a 1% of the 200s, which hopefully is the very large majority of all of the traffic you're seeing. Hopefully. Okay. So what can we do with the data? I mean, this is the point, right? We have now figured out that you the data looks very different, right? So the traces are proportional to the number of requests you get. Metrics are not proportional to the number of requests you get. Metrics are the same volume of data no matter how big your request traffic is, because they're a single number which measures over a point of time. And logs, logs are kind of related to the size of requests you get, but it's not a straightforward or a simple relationship. One thing which is also important to note is that because the data has that different shape, don't be tempted to think, I can get away without one of these because I can reconstruct stuff from the other data sources. Lots of people tried that. I don't know anyone that's had a good experience. If they've run it for long enough, sooner or later, something breaks and something which they just couldn't see because they didn't have the right data being collected. So what are these properties if I wanted to go up to an even higher level and say what are the things that differentiate these data sources? Well, metrics, you can time them and you can graph them, you can produce trend lines, and they can be aggregated. Logs, you can grep for results, right? That's the great thing. You can just get onto a logging box and it's just a stream of lines which you can do regexps and all sorts of other analysis on to find what you're looking for. So they're about discrete events, and they're about just essentially semi-structured text. And traces allow you to figure out what is slow or unresponsive or not working, and their big characteristic is that they are request scoped. So they are proportional to the number of requests you get, but you can also do some things like faceting on, well, let's suppose you're doing an A/B deploy. You've rolled out a new version of the code to 10% of your plant. If your observability system has been set up correctly, and you suddenly notice, oh look, the number of 400s or 500s is suddenly going up, or the overall response time for those components on what's been upgraded is shooting up, you should be able to spot that. You should be able to see that coming, and you should be able to issue a rollback before you get any angry customers. Those are the types of operational things we want to do with this data. And these are sort of some of the actionable insights that you can get from it. So a service alert you could get from a metric, timeout you get from a tracing, infrastructure and configuration you might see from metrics. Things like memory leaks you'd see from metrics and logging. So to finish this section, and before we move into the second half of the talk, what don't we do? So 2 anti-patterns for you to think about. The first of them is to abuse log correlation. What does that mean? Well, lots of people think, I don't want to implement tracing, it looks like a lot of work. How about we just stick an ID in all of our log messages, and then I can grep through and find all the messages with that log, and then I can produce a trace from that, right? Sounds like a great idea. It's absolutely terrible. Because it only works if all the log components are set up correctly, if the IDs are created the same way on each instance, if the IDs don't contain any PII. One memorable case I saw recently, the IDs were base 64 encoded versions of PII. So as soon as you found that, you could just decode it, and oh dear, that was not good. And then, of course, the logging system needs to be able to keep it with 100% of flow. And it's also very expensive, and you end up maintaining a lot of custom code to deal with this rather than having tracing out of the box. So the takeaway here is use a proper tracing solution. Don't build one on top of logs. Because if you do, you're basically doing this. Yeah, at the back.
An example of that, like aspect logging.
Is that an example of?
Like aspect logging in that library?
Yes, that's the sort of thing that people typically use when they're trying to do that. The other thing which we don't do is we don't shoehorn into metrics. Metrics are counters and gauges, right? They represent data aggregated and collected over a fixed time period. You shouldn't try to do anything like too much like shoving bits of log or shoving bits of trace into them. So it's also fair to say you need to be careful with histograms and percentiles when you're using them for metrics, because there are some statistical subtleties here. And if you get them wrong, you will end up with bad data. And don't abuse dimensions. Yeah?
About the percentiles, aggregating on percentiles or percentile bias. Aggregating the percentile is probably completely low.
Yes.
So how do you deal with situations where you have high volume, you have a lot of dimensions that it kind of scales up the metrics, but also you need to have visibility of tail latencies, let's say. So how do you kind of balance it out?
Yeah, that is not an easy question to answer. I think there are people who are trying to do some clever things with histograms, and histogram research is still very active. And I think that is probably the answer, is you probably find histograms that are aggregatable in some sense, rather than using percentiles directly. But yeah, great question. Okay, so yeah, don't collect absolutely everything, because not everything matters. In the OpenTelemetry working group, we had a discussion about whether we should add a metric for the 5-minute load average of a server. And I was like, that's completely useless, because if that ever breaches some threshold and it's come over a 5-minute period, your container's already dead, right? Kubernetes has already killed you and sent you off to the happy hunting ground many, many minutes since. And then the response was, well, they have it in JavaScript. And yeah, and it's useless there as well. So don't assume that just because you have the ability to collect everything, you should. The question you should always be asking is, what does this help us debug? What does this help us spot? And if you can't think of a good reason, maybe you don't need it. Okay, architectural implications. I'm going to go really quickly through this. There's 4 main ways that you can do observability. You can buy a vendor solution, which essentially means you're going to aggregate your data on the host and you're going to send it into some sort of third-party SaaS. That's a perfectly reasonable thing to do. People always, I think, have worry that it's going to cost a lot. Sometimes it does, but maintaining your own observability systems also costs a lot. So it's kind of swings and roundabouts here a bit. There is a possibility of sending everything, unsampled trace data into SaaS. But there's a majorly important subtlety here. You can only do that within a cloud region. Because if you try to do it to a different cloud region, you will pay egress bandwidth from AWS. And for the amount of data you're sending, you very definitely don't want to be doing that. Because that can be a vast amount of money very quickly. Okay, so this is sort of like 1.5. If you have clusters, so if you're running in Kubernetes, actually I should ask that as well. Who's running in Kubernetes? Yeah, lots of people, okay. Interestingly, there are people running in Kubernetes who didn't put their hands up to say that they were containerized. So I'm not quite sure how that works, but never mind. So there are things which can work on the cluster itself. And a particular technology here that I'll point you out is one called eBPF, which is a kind of a kernel level technology. It's not super useful for Java because Java does so much in user space, which is transparent to it. But it is useful in general as a tool. The drawback to doing this, of course, is yes, you're on a cluster, so it doesn't matter how much data there is. You can really push the boat out and take as much data as you want, but it doesn't correlate problems between clusters. So you are just kind of restricted to what you can do on a single cluster. You end up effectively deploying a small observability system, 1 per cluster. And that's probably not what you want to do. And then finally, you can roll your own. So I think I'll just skip through these architecture diagrams. Apart from this one, just because I think it's fun. So basically, all whether proprietary or open source vendor systems that I know of look a bit like this. You have some sort of data gathering agent, which may actually be an actual Java agent in the case of Java apps. You've got some sort of data pipeline, which is very often the OpenTelemetry collector, some sort of ingest pipeline, and if that looks a bit like a stylized Kafka logo, well, you can probably guess why. And then from there, you have a data store, some microservices which analyze it, and then some sort of front end, which has got a data analysis tool built into it. Basically, pretty much, this is what people want to build. This is what an observability pipeline looks like. This leads to a view of what's basically called a streaming architecture. There's a load of really interesting technology in here, but that's kind of specific to the building of these types of pipelines. You have to get concerned about late data. You have to be concerned about data that gets a bit lost. There's a whole bunch of stuff in there. There's 2 blog posts from some of the folks at Google who helped develop some of this. The first one, at least, is very accessible. So if you are interested in that type of streaming tech, then go for it. Just let people finish taking pictures. Yep. So to wrap up, this helps us handle the complexity of modern architectures. we're trying to find answers, specifically outage-related answers about the application. It's more a mindset rather than a practice or a product. There are many different ways to do it. And it kind of absorbs and extends classic monitoring systems. Lots of people have started with a monitoring system and have ended up building observability on top of it as well. So let's talk about OpenTelemetry. I'm just going to go through some of this fairly quickly now. So OpenTelemetry logs are probably the first thing to... That slide is well out of place. I'll come back to the logs. So where did it come from? Well, originally APM and monitoring was totally dominated by vendor solutions and proprietary. Lots of open source projects got started up. As I mentioned earlier, there was this sort of inflection point in the market where, and it's kind of easy to see why, because even the proprietary vendors had a problem. Because if you're one company, if you're Datadog, you need engineers who can cope with all of the different languages that your customers have. You know, Java, .NET, Python, PHP, Ruby, the list goes on. And then all the frameworks in those. So the amount of staff you need to deal with what your customers are actually deploying just keeps going up and up. But you're not alone in that, because your competitors all have the same problem. So you have this enormous duplication of effort just to keep up with the continuing evolution of the software market. And I don't know about everyone here, but I certainly don't see any consolidation. I don't see languages getting less popular. I see increasing diversification. So that problem is just getting worse and worse. And so to solve it, what do? You get this moment in the market where competing companies suddenly realize, hang on a minute, we cooperated on a common base layer. We could free up all these engineers to go and work on actual customer features rather than just what is basically plumbing, what is basically moving the data from place to place. Okay, so that's what caused, I think, the big shift in towards open source being a big part of it at that lowest layer. So OpenTelemetry, what is it? Well, it's a set of standards, formats, and libraries. It is fundamentally, well, remember how I said you need to get your application data, observability data out of the application and somewhere else, right? It's the bit which goes up to somewhere else. What happens to it after that is not the concern of OpenTelemetry. It's a library, which is effectively client-side. It's a standardized wire format, where you write the data into a format which is then carried across the network. And yes, there is a data terminating piece called the OpenTelemetry collector as well. That is it. There is no data storage, there is no search, and there are limitations as to how much correlation there actually is between the different data signals. It does aggregation, and it can do that at different layers and scales. The way that I think about these things sometimes is that there are some successful scalable technologies that start small and can grow to be big. There are other successful scalable technologies that start at very large scale and can be scaled down. And then there are things which, like Kubernetes, start at large scale and can be sort of scaled down. OpenTelemetry is a start big, but scale down smoothly. So it does work on small clusters, it does work on just individual applications, but it is designed to also be usable at very large scale. There's a load of people in the design of it who came from Google and who are used to dealing with many, many, many thousands of instances. What else can we say about it? It's cross-platform. It's not a Java-specific technology. It is an open standard, and it is designed to work, especially the tracing part, in systems, in applications, where not all of the microservices are written in the same language. So you can deploy OpenTelemetry tracing where you have a mixture of Java and Go and Node. That's not a problem at all. And those things, if you set it up correctly, will just play nicely, and you'll be able to see those services just as services without needing to care about the tech stack. Java is a very mature implementation. There's a lot of interest in it. There's a lot of good folks working on it. Go, .NET, Node, they're also getting there. Some of the other languages like Python are a bit middle of the road still, but we're getting there. It works with bare metal and VMs, but it is very definitely cloud first and cloud native. I'll skip that one. So how well does this diagram come out on the big screen? Actually not bad. Right, so there's basically three parts to this. There's the one that users and many developers care about, which is this one, the SDK. That is basically the default implementation of the API. The API is used by some people with special use cases, but most of the time, most folks just want the SDK. You will also notice that it defines long-term support, and it defines long-term support as the API will be supported for 3 years, and the other pieces will be supported for 1 year. Many enterprise customers would not exactly regard that as long-term support, so there are lots of companies who have stepped up to try to sell you support for those pieces as well. So what's in these pieces? Well, the API is for developers to instrument libraries. The SDK is basically for application owners, so that's your default implementation. I'll move on to the next slide. So the other components we have, apart from the API and the SDK, can be thought of in these 3 swim lanes here. You have a specification. That is an open standard, like an RFC or W3C standard. It's actually owned by the CNCF, the Cloud Native Compute Foundation, but it is a genuine open source standard which anyone can participate in, and it has a very open process. Lots of developers find standards work pretty bureaucratic and not that interesting. So I think more focus from the dev side, if you do want to get involved, will be on the instrumentation piece. So this is one-time work where every library, every language will develop instrumentation to automatically plug into every important thing in their ecosystem. So for Java, this is going to be JDBC, it's going to be Spring, you name it, there is going to be instrumentation developed for it. And a lot of that work has already been done, but there's always more to do. So if you are thinking, I need a new open source project to come and join in on, then there's always room for folks on the Java OTel project. And then finally is the collector, which is vendor neutral. It's kind of funny, it's called the Open Telemetry Collector, but I actually think that's a really stupid name for it because it doesn't actually collect data. It terminates the network connection, and then you have to provide something to do something with the data you've just got. So it's not really collecting anything. And it speaks about 15 protocols, not just Open Telemetry. So it's not just Open Telemetry, and it doesn't collect. But I know that ship has long since sailed, and I'm never going to convince anyone that it's actually time to change the name. Okay, so you could argue, ask the question if you're feeling cynical, is this just APM with new marketing terms? And the answer is, I don't think so. For one thing, it's got vastly reduced vendor lock-in. If you speak Open Telemetry, you can point it at any vendor that supports that. And increasingly, because of that shift that I was talking about in the open source world, it's table stakes. I can't think of a major vendor who at this point in time, in 2023, does not support Open Telemetry. I know that in the first year that New Relic were operating an Open Telemetry solution, which it was in beta for half of, it grew to be 1/3 of their traffic inside 12 months, which is just staggering. That is billions of messages a minute from a standing start in 12 months. So that's one of the reasons why I feel so comfortable, if I were to make a bet, that OTel is going to get some serious traction. When I talk to customers about this stuff, this is what they're all moving to. And the other market signals that there are about just how much data is being moved through OTel. Gartner said it was going to be half of all observability traffic by the end of 2023. And at the time I looked at that number and I thought, Gartner analysts that don't know anything, what a surprise. And these days I'm looking at those numbers and I'm thinking, you know what? I think that's pessimistic. I think it's going to be more than that. So that change in the market, I think, and the fact that it is all open source, it's open specification, and increasingly we have standard architecture patterns. Little bit short of time, but one of the ones I will mention is I've now seen in 3 separate banks where they had their own bespoke monitoring system that they're trying to get rid of, and their solution is to introduce an open telemetry layer, change the clients so that rather than writing proprietary observability data, they're writing open telemetry and then writing a plugin which goes into the collector and then adapts it back into the back end. And then, of course, at that point, you've decoupled the application teams and they can get on with doing application stuff, and the teams that are responsible for running the observability system can then migrate to whatever they're going to migrate to. So that pattern is extremely strong. And so this leads us to a sort of open source approach that looks a bit like this. I'll skip on a bit. So what's the current status? Well, distributed tracing is at 1.0. Metrics is at 1.0. They're both ready to go out of the box. Logging is still in draft, and it won't reach 1.0 until later this year. I mentioned this before, different languages have different maturities. Fortunately, Java is a very mature one. What about the competitors? Well, traces have no serious competitor. There is, yes, Zipkin is still out there technically, but it's been a very long time since I saw anyone running it. And open tracing, like, shut up shop. Jaeger's traces, they have actually deprecated. So Jaeger now speaks OpenTelemetry natively, and they are no longer going to support their own client protocol. So basically, in the tracing space, it's open telemetry. That's what's there. Metrics, Prometheus. Yes, Prometheus is going to be around for a while, but architecturally, people are starting to realize that Prometheus is not actually a great approach. The needing to come and scrape stuff, which means you need to know what's running, which means that you can't really do things like function as a service very easily, because those things just pop up and disappear again before Prometheus ever gets to hear about them, that actually a client push approach is a much better way of doing it. So it's early days, but I'm starting to see more people who want to do OpenTelemetry metrics rather than Prometheus. Because remember, all this thing is it's a way to get data out of your applications. It goes to a collector, and guess what? There is a Prometheus plugin for the collector. So that rather than coming and having to scrape every application and every pod and every container that you need to know about, you funnel all the data into a collector and make that the thing which is well known. So that Prometheus can just come in and scrape it. At that point, you can evolve your backend separately again, and you can reuse that same pattern. So I will skip the collector, because it's interesting, but we're a bit short of time. The key to all of this is OpenTelemetry Protocol, OTLP. It defines encoding, transport, and delivery. It is HTTP2, and it's typically encoded as protobuf. Some people want to do this as JSON. I think that's a terrible idea. The performance of it when using the JSON encoding is significantly impaired, and this is a performance-critical system. So most people who are sensible do this as protobuf over HTTP2. We use gRPC in Java, and this is designed to be high performance. I'm working on some benchmarks, but they weren't quite ready to show for you today. But if you keep an eye on the Red Hat developer blog, you will see some posts about the actual genuine overhead of OTel in a real-world system. Designing those test applications is quite tricky, but I think we've got something that we're reasonably happy with now. So for Java, what do we do? Well, we can do manual instrumentation. We can add in stuff to simply put things in our application which are going to manually start and end traces. This is error-prone. It's extremely difficult to get right, and in general, it's not the way that we like to do it. So for tracing, what people have landed upon mostly is automatic instrumentation. So there is a Java agent for OpenTelemetry which you can use. It's fully production ready, and it will just automatically instrument your apps for traces. So if you set that up with a back-end instance of a collector and Jaeger, and the initial slides that I put up, I had some examples of things which will bring up that collection, just a Docker Compose script which will bring up a test app, and here is a piece which will bring up your collector and Jaeger in the back-end. There are three main projects, so if you want to dive into this, everything's on GitHub, the standards, the implementations, everything. There's the OpenTelemetry Java, which is the API and the SDK. There's the auto instrumentation agent, which is the one which does automatic tracing. And then there's a contrib, which basically is the incubator. So that's either standalone libraries or things which are not fully baked enough yet to go into the main libraries. My big project in OpenTelemetry so far has been the JFR support, the Java Flight Recorder, which is currently still in contrib and is just about to go into the main instrumentation libraries. So that's been a collaboration between myself and some old friends from New Relic, and that's been a really good experience. So OTel is a very active, very high quality, and very interesting project to work on, and the community. Right, so I'm going to skip the auto instrumentation piece and come to the final section. So the conclusions and roadmap. So observability is reaching more and more developers. I think I saw a number, this may actually have been a New Relic number, that they saw a 30x increase in the number of OTel collectors in 12 months. So that's astonishing. That and the data points for how much data they're collecting, I think are pretty amazing. The logs, which is the one missing piece of OTel, I think will probably go 1.0 in summer, and we expect to see this become the majority of data in 2023. The challenges, there's still so many tools and different technologies in use. There is still an education gap where people don't really understand what their options are, because it is such a big space. The question about observability architecture is becoming clearer, but I think that message still needs to get out to a lot of developers, whether you're going to build one yourself out of open source components, or whether you're going to go down the vendor route. OpenTelemetry itself is still maturing, and some people don't like supporting standards that aren't fully baked yet. Now that we have metrics and traces at 1.0, I would hope that attitude will be shifting. We always need more participation in our open source groups and our standards. There is an end user group, which is actually a good place to start contributing if you're not ready to start taking on the coding of the actual libraries themselves. So if you're thinking about deploying OTel, the user group is a great place to start from. We have an active Slack with many participants, including basic support for folks that are just starting out. It's a very broad and very welcoming community, and we'd love to see you there. And thank you very much. So this is my new book. I have a discount code here for everybody. And at this point, I'll take questions, because I do actually have a few copies of this to give away. Yeah, at the back.
What are your thoughts on log-based metrics?
What, routing metrics data over logs?
Yeah, using your logs as, is that like a good strategy, or is that like lazy or a way of doing it in the legacy world?
I mean, I think if you don't have a metric solution already, you can use something like Micrometer to put it into a log, because you'd have like a log-based exporter for Micrometer, and then that would go into the log file as a first step. Because then what you've done is that you're writing to the metrics API, it's just done on a different transport. And then when you actually are ready to switch over to a proper metric system, all you have to do is change the exporter. So that is probably the approach that I would take there. In general, the problem with semi-structured data is that you've got to burn compute in order to get stuff back out again. Whereas if it's just metrics data, it's going to be a lot more efficient. But if you need to do something quickly and that's what you've got, that might be a good idea. But as with all of those things, that looks like a big piece of technical debt that you should get rid of. It's good.
You can do when you first start, it's like I want to count the number of this log, but
yep.
It seems like it needs to be moved up to those metrics, proper metrics from the app.
Yeah, it's a good question though. Come and see me when I'm done for a code. Yep, who's next?
So Java, well matured. What about like raw VM native images?
Okay. So that's a very interesting question. So when people think of native image, what they're mostly thinking about is startup time. Is that what you're thinking about?
Well, I guess, so like, we use Datadog, we're looking at open telemetry as, a go-between mechanism, so we can have that standardized bit here. Let's have an enterprise solution, which customers would install. We don't want to be the arbiter of, hey, you need to use this as well. Datadog, for example, then their agent, since you're in raw VM, the agent, compiling that in, it doesn't exactly work the same because it's not the same VM or anything of that nature. So then, even just getting the image together and then actually getting the data out of your program while it's running doesn't work with their agents. So I'm curious how that works with open telemetry and if there's any caveats to that type of a runtime versus on the game itself?
Yeah, so there's huge amounts of caveats. Part of the thing here is that the native mode is still not baked. I mean, basically, there is no standardized way of talking about native Java, right? There's what GraalVM does, and then there's Leiden, but Leiden is years out in terms of what it's actually going to deliver. But what I would say is, depending on exactly what your application is doing, there may be other solutions. If what you basically care about is the startup time of your app so that you don't have a cold start, native is not the only way to do it. I mean, the way that we do this in Quarkus is we have like a build step, and the build step moves everything that it possibly can and front loads the process so that when you're ready to go, you've actually basically made things a lot more static so that the start times absolutely go through the floor. Now, it's a slightly different programming model. I mean, it is just microservices, it is just RESTful stuff. So people do pick it up pretty quickly, but it does mean adopting a new stack. And with Graal, it's still in its early days. I mean, one thing I can tell you is that some work that my friends in the monitoring group are doing, JFR events are coming to GraalVM, including in native mode. So JFR will be a source of data, and will we be able to get full OpenTelemetry out of that data? Well, we'll be able to get the metrics out, but traces might be more of a problem. There is also work that's been done to get the OpenTelemetry agent to compile in native mode as well, but that is tricky. I got partway through that, and some folks at Microsoft got partway through it as well, and we concluded that this was not the right time to try and, we didn't have the cycles to finish it. But yeah, some good questions, and we could talk about that quite a lot more, so come and find me later if you want to. Right, so that's two books handed out. Yeah, come and see me for a code afterwards. Yes?
I was just curious, it seems like you were hinting at it at a couple points in the talk, talking about profiling and JFR integration with OpenTelemetry. I was just kind of curious about what that might hold for the future.
Yeah, totally. So let's talk about the JFR piece first of all. What's going in well, as soon as the PR gets merged, is the standard JVM metrics, which was a piece that we added so that you can get not only application level metrics in OpenTelemetry, but also things which have come directly out of the VM. Now, there's two obvious ways to get that, JMX and JFR. So we actually wrote a specification which can cover both cases. So that is the standard thread counts and class loading and CPU and all of that good stuff, you will be able to get out of JFR as well. Profiling is brand new, but it is entirely possible that it will become a fourth or a fifth pillar of what's available in OpenTelemetry. The work is at a very, very early stage. I've been dipping in and out of it when I've had time, but there are some smart people at Red Hat and other places working on it. Profiling is complicated because you need to get stack traces, and then it's very easy for the data to get out of control and for you to be suddenly sending a lot of data and also putting a lot of strain on the application. So then the other architectural problem, then I'll stop, is you then therefore need to be able to control what the profiler is actually doing, because it needs to run in quiet mode a lot of the time, and then you have to be able to say to it, right, and now start sampling a lot more aggressively. So that then implies, because OpenTelemetry is just a push model, right? You're just pushing data out. Now you need a control plane because you need to be able to tell the profiler, hey, you need to do stuff. So that's the issue. But a good question. Okay, any more?
Yeah, just one. Are there any good patterns for tracing data through like really distributed systems, say like nano services that are really wired together through PubSub style metrics? That's a big challenge for us.
Yes, so if you come and talk to me afterwards, we can talk about exactly which messaging systems you're talking about. OpenTelemetry support has been added, some of it was added by Red Hat folks, to some of the PubSubs, but it is a little tricky. Yep. Okay, folks, I think we've probably, I should call it because, well, I think people need a break, but come and ask me afterwards. Okay, thanks everyone.